Hello everyone, welcome to the mathematics in my channel. In this video we are going to solve this nice integral from 0 to 1 x to the m over 1 plus x to the n. So I think this is a very important integral. So when solving some integrals we have to use this integral directly. Okay, how to begin? Well, as a first step, here integral from 0 to 1 x to the m over 1 plus x to the n, and now I am going to multiply both numerator and denominator by 1 minus x to the n. Here also 1 minus x to the n dx. Now let's simplify. Here integral from 0 to 1 x to the m minus x to the m plus n over in the denominator we have the difference of two squared, so we have 1 minus x to the 2n dx. Okay, let us take the substitution. Here we have x to the 2n, so let's take x to the 2n is equal to t. Then if we differentiate, 2n times x to the 2n minus 1 dx is equal to dt. Also we can isolate the x we know, t to the 1 over 2n. Well, let's plug in. Now we have integral from 0 to 1 x. We have x t to the 1 over 2n, so t to the m over 2n minus x, again we have t to the 1 over 2n, so m plus n over 2n over here 1 minus x to the 2n we know, t times dx we have dt over 2n times x to the 2n minus 1, so we have t to the 2n minus 1 over 2 times n. Well, let's simplify. Here 2n constant, so 1 over 2n integral from 0 to 1. Now here we have t to the 2n minus 1 over 2n, here t, so we can simplify. Here t to the m minus 2n plus 1 over 2 times n, then minus t to the m plus n minus 2n plus 1 over 2 times n over 1 minus t dt. Okay, then again I am going to rearrange the powers like 1 over here 2 times n integral from 0 to 1. Now t to the m plus 1 over 2 times n minus 1 minus t to the m plus n plus 1 over 2 times n minus 1 over 1 minus t times dt. Okay, now the integral format, here we have an integral, so we can write this integral 0 to 1 x to the a minus 1 minus x to the b minus 1 over 1 minus x dx. This is the type of integral. So if we evaluate this integral easily, we can find the answer of I. Well, how to evaluate this integral? Okay, let's evaluate. Now I'm going to divide it by 1 minus x, so 0 to 1 x to the a minus 1 over 1 minus x to the b minus 1 over 1 minus x, and here we have dx. Then as a next step I'm going to add the 1 over natural log of x, then here plus x to the a minus 1 over 1 minus x, then minus, here we added the 1 over natural log of x, so we should subtract 1 over natural log of x, so here 1 over natural log of x plus x to the b minus 1 over 1 minus x, here dx. Well, now what is the next step? Okay, let's recall the integral representation of diagram of c. We know diagram of c is equal to integral from 0 to infinity e to the minus x over x minus e to the minus c times x over 1 minus e to the minus x dx. Now I'm going to take a substitution. So I'm going to take t is equal to e to the minus x. Then we know minus x is equal to natural log of t. Also, if we differentiate, dt is equal to minus e to the minus x dx. Okay, let's substitute. Now limit we know 1 to 0. Then e to the minus x we know t, and x we know minus natural log of t. So we have minus t over natural log of t. Then here minus e to the minus z times x. So we have t to the z over 1 minus here t and dx we know minus 1 over e to the minus x. So minus 1 over t times dt. Well, then here minus sign. So we can change the upper boundary and lower boundary. When we change the boundary, we know this minus sign get cancelled. And also here we have minus, here minus. So I'm going to take again minus sign as a common factor. So here we have, now we know this t and this t get cancelled. So 1 over natural log of t, then plus t to the, here c, here t, so t to the c minus 1 over 1 minus t dt. Now we know this integral from 0 to 1 over natural log of x plus here t to the c minus 1 over 1 minus x dx is equal to minus digamma of c, minus times digamma of c. Therefore we know here we have this type of integral here. So we can write now this is equal to digamma of b minus digamma of a. Here b, so we should write first digamma of b minus digamma of a. Therefore our integral I, we know this is equal to I. Now we can write I is equal to 1 over 2n. So I is equal to 1 over 2n times digamma of m plus n plus 1 over 2 times n minus digamma of here we have m plus 1 over 2n. So m plus 1 over 2 times n. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.